find the intervals on which the given function is increasing or decreasing. So in this example, we need to find the intervals on which the given function is increasing or decreasing, and the function given here is just x square minus 4x plus 5. So how can we find the intervals on which the x square minus 4x plus 5 increasing or decreasing? There are actually a couple of ways to do that, but on this example we'll try to see how to use the increasing and decreasing test. Okay, so we'll be going to use increasing or decreasing test. So this is the test we are going to apply to see DECREASING, decreasing test, right? So we are going to use this test to determine either given function, where the given function is increasing or decreasing. So how can we do this? Before we need to see how can we evaluate or how can we determine the given function is increasing or decreasing, we need to see what increasing and decreasing test mean, right? So because we are going to use this test. So what is increasing decreasing test? So to apply increasing decreasing test, what we need to do is, if we have given a function f, let's just find first what is f prime of x. Okay, so find the derivative of the given function, and the increasing decreasing test says that if the derivative is positive, then the given function is increasing on the interval where the derivative is positive. So if f prime of x is positive, then that will imply the function is increasing on that interval. In the same way, if we figure out that the derivative of the function, it turns out that we also figure out where the derivative is negative, then if we do that and we figure out on which interval the derivative is negative, on that interval function is also decreasing. So we are going to use this test, okay, over here to determine. So you might have noticed, to begin even with, to use the increasing and decreasing test, we just need to first find what is the derivative of this function. So what is the derivative of f of x? By using the basic differentiation properties, we can find the derivative of the x square, which is, what is the derivative of the x square? 2x, right? And then we have minus 2x. So derivative of that with respect to x will be negative 4, right? And what is the derivative of positive 5? Positive 5 is a constant, so derivative of that will be 0. So 2x minus 4 is only the derivative of the given function, right? So we figure out the derivative, but to apply the increasing and decreasing test, we need to see where the derivative is positive, where the derivative is negative. To do that, that is also can be done with couple of ways. What I want to do here is I want to actually use the sign chart of f prime. So how can I do that? So let me first write down, I want to create the draw the sign chart of the derivative function. So to do that, we need to first draw a real line. Let's say this is from negative infinity to positive infinity, right? So this is the real line, let's assume. So what we need to do is, once we draw the real line, you need to know what is the domain of the function. So if f of x is x square minus 2x plus 5, what is the domain of that? All real number. Okay, so then this is good, so we don't have to do anything. And then after that, what you can do is, where the derivative is 0 or the where derivative does not exist, find those location. So how do we do that? Well, first check if the derivative does not exist at some location. This is 2x minus 4, right? Is the derivative of the function 2x minus 4, and that is also like a polynomial, and it's defined everywhere. On that case, we will not find any location where the derivative is not 0. What am I talking about? Derivative does not exist, right? I'm jumping around. Okay, so we just, by looking at that derivative, we saw that the derivative does not we could not find the location where the derivative does not exist. So the next thing we need to figure out is then to see where the derivative is 0. So where f prime of x is 0, so that's what we need to figure out. How can we find it? Well, we can see that the derivative is 2x minus 4, so write it down and set it equal to 0, right? And then just solve for x, which is 2x is equal to, add 4 on the both side, divide by 2 on the both sides, so we get 4 divided by 2 will be 2. So we figure out that at x equal to 2, probably somewhere around here, the derivative is 0. Alright, so this is how we can try to begin with to figure out the sign chart of the f prime. We try to see where the derivative does not exist, where the derivative is equal to 0. Okay, on the domain of the function, and the domain of the function on this case is all real numbers, so we figured this out. And this number where the derivative does not exist, and where the derivative is 0, and where the function even does not exist, or function is undefined, those locations are called partition number of f and f prime. So we find that. So on this case we have 2 is the only location where the derivative is 0, so that is the only partition number. Alright, so use that to partition the given domain of the function, and the domain of the function is all real number, right? So we have that. Okay, so now let's try to create the sign chart. To do that, let's choose any random number over here on this interval from negative infinity to 2. So let's say assume that is what I like, 0 lies here, so I like to just choose that random number. If you want to choose 1 or any random number between negative infinity to 2, whatever number you can choose. Okay, in the similar way, choose any random number from 2 to infinity. Let's say 3. You can choose any other number, and when you choose this random number, plug back into the derivative. Okay, so what is f prime of 0? Let's find the f prime of x at 0. So when you evaluate the f prime at 0, what do you get? We need to replace x completely by 0, so we get 2 times 0 is 0, 0 minus 4 is negative 4, right? So if that is the case, we can say the sign of the derivative within this interval from negative infinity to 2 will be negative. You can check any other number and then check on the derivative, and then you will still get the same answer. In the same way, from 3, so from on the interval from 2 to infinity, let's check when you 3 plug back in on the derivative, what is the sign you get. That means let's evaluate f prime at 3 and then see the number. Okay, so when you evaluate f prime at 3, we get 2 times 3, which is 6. 6 minus 4 will be 2, so that means it is actually a positive number, so write down plus here. So when you do that, you can clearly see, we can clearly say that f prime is positive on this interval from 2 to infinity. So what did we determine here? So it seems like f prime is negative from negative infinity to 2, right? Okay, so if that is the case, I can say that since f prime is negative where on negative infinity to 2 on this interval, right? So by which test? Increasing and decreasing test. What will happen when f prime is negative, then f is decreasing. So what can we say? By increasing or decreasing test, let me write down that I/D, right? Increasing and decreasing test, it is, our f is increasing. Is it so? F prime is negative, right? So it is actually decreasing on negative infinity to 2. Makes sense? So since within this interval, you can see here on this interval from negative infinity to 2, given function, the derivative was negative, so by the increasing and decreasing test, it is decreasing. Now can you tell me where the function is increasing? Well, we just need to see where the derivative is positive. And we can say that also, since f prime is positive on where? From 2 to infinity on this interval, by increasing or decreasing test, f is increasing. That's what it is saying, right? On this increasing decreasing test when f prime is positive, so on this interval 2 to infinity. And we are done. So we know now where the function is increasing, where the function is decreasing by using the increasing decreasing test.